Today's edition of SpaceTime is brought to you by our new sponsor, Brilliant.org. Maths and science done right. Learn to think like a scientist with their carefully curated lists of puzzles and questions. Check them out today and use the link brilliant.org/Stuart Gary so they know you've come from us. Once again, that's brilliant.org/Stuart Gary. This is SpaceTime, Series 20, Episode 76. Coming up on SpaceTime, a fourth gravitational wave detection, discovery of the pitch-black planet that eats light, and a new Pluto mission proposal. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have achieved a fourth gravitational wave detection of merging stellar mass black holes. The new discovery was a combined effort between the existing LIGO laser interferometer gravitational wave observatory detectors in Louisiana and Washington state, together with the new European VIRGO gravitational wave detector near Pisa in Italy. The new detection, made on August 14, 2017, was generated by the merger of two black holes about 1.8 billion light-years away. The new event, named GW170814 and reported in the journal Physical Review Letters, involved stellar mass black holes of about 31 and 25 times the mass of our Sun. The newly merged black hole has a mass of about 53 times that of our Sun, the remaining three solar masses all being converted into gravitational wave energy during the collision. The LIGO detectors work by using a laser split into two beams and fired down two 4-kilometre perpendicular tunnels to reflectors at the far end, which then send the beams back to be recombined at the detector. Gravitational waves, generated by the mergers of massive objects such as black holes or neutron stars, pass through the detectors, causing the very fabric of space-time to be ever so slightly compressed and expanded by less than the width of the nucleus of an atom. Still, that tiny amount is enough to be detected by the LIGO lasers. Using multiple detectors allows astronomers to determine where in the sky the merger took place. One of the study's authors, David Shoemaker from MIT, the Massachusetts Institute of Technology, says the latest discovery, which included observations from the new European VIRGO detector, means the next observing run, which is slated to commence in about a year's time, can expect to make detections at least once a week. The merger was detected by VIRGO just 2 weeks after the upgraded laser interferometer formally commenced observations. It took scientists and engineers 6 years to upgrade VIRGO to match the advanced LIGO standard. Of course, it's been just over a year and a half since the National Science Foundation first announced that its laser gravitational wave observatories had made the first ever detection of gravitational waves resulting from the collision of two black holes in a galaxy over 1 billion light-years away. The advanced LIGO detectors in Louisiana and Washington state began operating in September 2015. They began their second observing run in November 2016, and the VIRGO detector joined those observations on August 1, 2017. The real-time detection on August 14th was triggered with data from all three LIGO and VIRGO instruments. At present, VIRGO is still less sensitive than LIGO, but two independent search algorithms based on all the information available from the three detectors demonstrated the evidence of a signal in the VIRGO data as well. Overall, the volume of the universe that's likely to contain a gravitational wave source shrinks by more than a factor of 20 when moving from a two-detector network to one containing three detectors. A fourth detector is now under construction in India. That detector was to be built on Australia, but the Gillard Labor government who was in power at the time said no. The region of the sky for GW170814 has a size of only 60 square degrees, more than 10 times smaller than with data from the two LIGO interferometers alone. In addition, the accuracy with which the source distance can be measured further benefits from the addition of the VIRGO detector. This increased precision will allow the entire astronomical community to eventually make even more exciting discoveries, including multi-messenger observations. You see, a smaller search area enables better follow-up observations with telescopes and satellites for cosmic events that produce gravitational waves and are also likely to produce emissions of light, such as the collision of neutron stars. Increasing the number of observations in the International Gravitational Wave Network not only improves the source location, but also provides improved polarization information, and that provides better data on the orientation of the orbiting objects as well as enabling new tests of Einstein's theory of relativity. LIGO and VIRGO partner telescope observatories didn't identify a counterpart for the GW170814 detection, which was a similar outcome to the 3 prior LIGO observations of black hole mergers. That's probably because black holes produce gravitational waves, but not light. The new black hole gravitational wave detections comes amidst ongoing rumours about the possible first detection of collisions between neutron stars. However, at this stage, it would seem scientists are still keeping stum. But if something does break on that front, we'll let you know. You're listening to Space Time. I'm Stuart Gary. NASA's Hubble Space Telescope has observed a planet outside our solar system that looks as black as fresh asphalt because it absorbs virtually all the light it receives rather than reflecting it back into space. The study, reported in the astrophysical journal Letters, claims the exoplanet's light-eating prowess is due to its unique capability to trap at least 94% of all the visible starlight falling into its atmosphere. The oddball exoplanet, known as WASP-12b, is one of a class of worlds called hot Jupiters, gas giants which orbit extremely close to their host stars and are therefore heated to extreme temperatures. Because it's so close to its host star, the gravitational pull from the host star has stretched WASP-12b into an egg shape and raised the surface temperature of its daylight side to a blistering 2,600 degrees Celsius, so hot that most of its atmospheric molecules are unable to survive. Therefore, clouds are unlikely to form and reflect light back into space. So instead, incoming light penetrates deep into the planet's atmosphere, where it's absorbed by hydrogen atoms and converted into heat energy. First spotted back in 2008, WASP-12b circles the Sun-like star WASP-12, located some 1,400 light-years away in the constellation Auriga. WASP-12b orbits its host star at a distance of approximately 3.2 million kilometres, approximately 1/44th the Earth's distance from the Sun. The planet takes just a little over a day to orbit its host star, in contrast to the 365.25 days it takes the Earth to orbit the Sun. The study's lead author, Taylor Bell from McGill University in Montreal, Canada, says astronomers never expected to find such a dark exoplanet. That's because most hot Jupiters reflect at least 40% of the starlight they receive. Like all ultra-close orbiting celestial bodies, WASP-12b is tidally locked with the same side always facing its host star. The Moon does the same thing in relation to the Earth. Consequently, the nighttime side of WASP-12b always faces away from the star and is therefore at least 1,000 degrees cooler than the daytime side. And that's important because it allows water vapour and clouds to form on the planet's night side. Previous observations of the terminator, that is the day-night boundary, detected evidence of water vapour and possibly clouds and hazes in the atmosphere. The new Hubble research further demonstrates the vast diversity among the strange population of so-called hot Jupiters. Past observations of hot Jupiters indicates that the temperature difference between the day and night sides of the planet usually increases with hotter day sides. This previous research therefore suggests that more heat's being pumped into the day side of the planet, but processes such as winds, which carry heat to the night side of the planet, aren't able to keep up the pace. The authors were able to determine the planet's light-eating capabilities by using the Hubble Space Telescope's imaging spectrograph to search in mostly visible light frequencies for a tiny dip in starlight as the planet passed directly behind the star. The amount of dimming tells astronomers how much reflected light was being given off by the planet. However, the observations didn't detect any reflected light, meaning that the daytime side of the planet is absorbing almost all the starlight falling on it. Interestingly, previous observations by Hubble's Cosmic Origin spectrograph revealed that the planet may be downsizing. That's because Hubble was detecting material from the planet's superheated atmosphere apparently spilling into the star. To find out more, Andrew Dunkley is speaking with Dr. Fred Watson from the Australian Astronomical Observatory.
The thing of science fiction that's come up in the news in the last week or so with the discovery by the Hubble Space Telescope of a pitch black planet. Now, I've seen a lot of science fiction shows and read a lot of science fiction books over the years, and these are always places of evil. What have we found?
Well, actually, its name is kind of threatening because its name is WASP-12b.
Well, that does sound evil.
Yeah, WASP is actually a project that basically looks for planets around other stars. It's a ground-based project using relatively small telescopes. It looks for planets around other stars by watching the star's brightness and looking for dips in the star's brightness as a planet passes in front of it. It's a sort of common method for finding planets these days. It's one that's been relatively well studied. It was discovered back in 2008, I think. It has, the reason why it's in the news today is that the Hubble telescope has been used to make follow-up observations of the brightness of the star and the way the brightness of the star changes as this planet goes around it. So a couple of vital statistics, Andrew. It's about 1,400 light years away. So, of course, that's in our own galaxy, but it's not in our neighborhood. It's not in the sun's neighborhood. So this is a fairly distant one. This planet is known to be about twice the diameter of Jupiter. So it's a big planet.
Wow.
And you can tell that by the amount of light, the star's light, it blocks off when it passes in front of the star. And that gives you its size directly. And then the regularity with which this happens tells you what the year of this planet is. And this planet has a year of 1 Earth day. So it whizzes around its parent star, which unsurprisingly is called WASP-12A. So what the planet WASP-12b goes round once a day in our time. And that actually makes it quite easy to study because you don't have to wait very long for it to pass in front of its parent star.
Yes.
But what the Hubble's done is something pretty neat, really. It's not just watched for the time when this planet is passing in front of its star and dipping its light. It's also looking out for the times when the planet is just about to go round behind the parent star and just after it has appeared from the other side of the parent star. You see what I mean? As it goes around its parent star, it's going to be on this side and the other side. So half a revolution after it's crossed the disk of the parent star, it's going to be going behind the parent star. Mm-hmm. And so just briefly before that and after that happens, you've got the light of the star plus the reflected light of the planet itself, which is contributing to the starlight. So if you analyze that very carefully, it tells you about the brightness of the planet. And that's what this work has actually produced, a measurement for the amount of light, of starlight, that's reflected off the planet. And it is incredibly small.
Which prompts so many questions.
Yeah, that's right, it does. So we know it's there because it blocks off the light of its star. But when it's on the other side of the star and contributing to the star's light, it's basically making virtually no contribution. We, in the world of astronomy, talk about something called albedo. And albedo is a Latin word meaning whiteness, how white a thing is.
Yeah.
And in fact, so the albedo of a surface is how much light it reflects. So, for example, the moon's surface is actually quite a low albedo. The moon reflects about 12% of the light falling on it. And actually, if it was more like 50%, the moon would be nearly as bright as day in our skies. Mm. Moon looks bright, but it actually is not reflecting all that much sunlight.
Yeah, I mean, let's just ponder that for a moment. If the moon was an ice moon rather than
exactly.
dusty old basalt, our full moon nights would probably be quite, we probably have daylight.
We might even have to wear sunglasses.
Yeah. It would be very weird.
Yeah, very weird. That's right. So your point is absolutely well made there. But this planet has an albedo about half that of the moon. It's only reflecting something like 6% of the starlight that falls on it. And that is a real puzzle. Mm. We really don't know why it should be so low. The thinking is that with a hot Jupiter-sized planet or twice Jupiter-sized planet like WASP-12b, you would expect it to be a gaseous planet that has a much higher reflectivity, as Jupiter does. It's different from Jupiter, though, because this planet has a surface temperature of well over 2,000 degrees. I think it's 2,600 or thereabouts, something like that. So it's a very, very hot world, and that doesn't really tie with a very, very dark world.
Yes.
So I think the jury's out on why that should be. And some very interesting research. And maybe, Andrew, it is just because it's evil.
It could be just that, yes. But it does. So do we know what it's possibly made of? I mean, we know a fair bit about closer planets. This one they've certainly been studying pretty closely too. But do we know what the formation is made of?
No, but we've got clues that come from the ability of the Hubble telescope not just to measure the light, but to measure the light in different colors as well. So that gives us an idea of, whether you're reflecting more light towards the blue end of the spectrum or the red end of the spectrum. And that is really it's the only clue that you've got as to what kind of things might be going on. But there are suggestions that there are some models that you can build of planets that have things that give you peculiar chemicals in the upper atmosphere of a planet like this, a gas giant, that actually absorb light. But the problem is that they only work for cooler planets than this one. This one's too hot for that mechanism to work.
Yeah, could it be something like there's an element in the upper atmosphere that
Yes.
lets light in, but then as the light penetrates deeper, there's something stopping it from bouncing back out again?
That's exactly right.
Yeah.
There's they talk about clouds and alkali metals and things like that. But as I said, these don't work because it's got such a high surface temperature, 2,600 degrees Celsius, as I was mentioning. So it is, a big mystery.
That's Dr. Fred Watson from the Australian Astronomical Observatory speaking with Andrew Dunkley on Space Nuts. And you're listening to Space Time. I'm Stuart Gary. Okay, let's take a break from the show and talk about our new sponsor, Brilliant.org. This is such a cool match between a sponsor and SpaceTime. People are always asking me about advice on how and where to learn more about astronomy and physics. And I can't emphasize enough how important it is to prioritize active problem solving, with things like lectures and readings serving as a supplement to that main goal of knowledge. And of course, Space-Time has always been designed to do both, provide news, while at the same time educating fans about the wonders of space sciences. But I think my greatest reward of all has come from those fans of Space-Time, as well as its predecessor Star Stuff, who are inspired to actively take a greater interest in science and astronomy. And that's where a sponsor like Brilliant.org comes in. It's one of those places you can go to on the net to learn more about science and about astronomy. The user experience is one of going through a very thoughtfully curated list of puzzles and questions. That's a lot of fun. A great exercise for your brain and a very productive way to expand your knowledge. I think anyone listening to Space-Time would really enjoy checking out their astronomy course. As you explore through it, you'll get hooked on all sorts of really interesting things, like how the ancient Greeks first estimated the size of the sun. You can learn more about this approach in the Sizing of the Universe chapter. And if you follow the link, brilliant.org/Stuart Gary, we'll put that in the show notes, it lets them know you came from here, and that way you'll be helping to support Space-Time. That's brilliant.org/Stuart Gary. And now it's back to the show. NASA's received a new proposal for a surface mission to Pluto. The new plan would follow on from the highly successful New Horizons spacecraft mission, which undertook the historic first ever close flyby of Pluto and its binary partner Charon back in July 2015. The company behind the proposal, Global Aerospace Corporation, says the project would include an integrated entry-craft architecture that can decelerate and gently land on the surface of Pluto from a speed of over 50,000 kilometres per hour, using only the drag of Pluto's ultra-thin atmosphere and a few kilonewtons of propellant. Once on the surface, the vehicle would switch to a hopper mode, taking advantage of Pluto's low gravity and a modest propellant store to literally hop around the surface, sometimes even tens to hundreds of kilometres at a time, investigating surface features of interest. Principal investigator Dr. Benjamin Goldman says Pluto's surface pressure is just 10 millionths of Earth's, but its atmosphere is extremely spread out, extending about 1,600 kilometres above the dwarf planet's surface. This extended and ultra-low density atmosphere is ideal for dissipating large amounts of kinetic energy by means of aerodynamic drag. But the key is making the overall drag area very large while at the same time keeping the system's weight to a minimum. To efficiently make use of Pluto's atmosphere for deceleration, the entry craft would need to be almost as large as a football field. Once it reaches the surface, the lander hopper will undertake scientific investigations designed to shed new light on Pluto's origins and also its relationship to other Kuiper Belt objects, as well as the solar system's planets. The mission would also characterise the dynamics between the subsurface and the atmosphere by investigating outgassing processes such as cryovolcanism. The mission design would allow science to expand its understanding of Pluto's surface geomorphology from multiple locations, on approach, during ascent, and on the surface. The mission would also carry out in situ sampling to study the nature of Pluto's crust and search for hypothesized liquid water subsurface oceans. And it would validate New Horizons' own measurements, including atmospheric pressure and temperature profiles. While landing on Pluto would be the primary focus of the proposed mission, it could also be designed to enable an orbital capture, with the atmospheric drag instead used to decelerate the spacecraft sufficiently to place it in orbit around the dwarf planet. If it's approved, the mission could be on its way to Pluto within 12 years. You're listening to Space Time. I'm Stuart Gary. CSIRO has joined a project to develop and operate one of the world's most sophisticated Earth observation satellites. The 430 kilogram synthetic aperture radar remote sensing satellite, known as Novasar, will launch later this year on an Indian PSLV rocket. The spacecraft will provide high-resolution observations of the Earth's surface from a 580 kilometre high, low-inclination equatorial orbit. The radar system would enable images to be taken day and night and through cloud cover, which is especially useful in tropical zones and other cloud-affected areas. The CSIRO says it plans to take a 10% stake in the project, giving it control of satellite mission operations over Australia and its territorial waters. CSIRO will then provide and process the downloaded data for the local scientific research community. The spacecraft's operations are designed to allow for rapid disaster identification, monitoring and assessments, including cyclones, floods, earthquakes, as well as pollution and oil spills. It'll also study surface infrastructure and agricultural activities, monitoring crop yields, and assessing plant biomass and soil moisture. Finally, the probe will also be searching for illegal logging and deforestation activities, as well as monitoring shipping routes and detecting illegal fishing operations. Australia is already one of the world's largest users of Earth observation from space data, with satellite operations underpinning more than 100 state and federal resource mapping and environmental monitoring programs across the country. The new agreement will allow the CSIRO to continue monitoring and analysing the nation's natural resources, as well as managing infrastructure. The spacecraft is being built in the United Kingdom by SARI Satellite Technology, with the S-band synthetic aperture radar system supplied by Airbus Defence and Space. A secondary automatic identification system payload developed by ComDev will also be incorporated onto the spacecraft. The probe will use a Xeon ion propulsion system for orbital manoeuvring and has a 7-year design life. You're listening to Space Time. I'm Stuart Gary. An Atlas V rocket has blasted into orbit from the Vandenberg Air Force Base in California, carrying a top-secret payload for the National Reconnaissance Office. The launch of the NROL-42 mission had been delayed by 2 days because of battery issues with the Atlas V booster. The mission eventually blasted off from Space Launch Complex 3E at Vandenberg into black late-night skies, which seemed more than appropriate for such a clandestine flight.
Status check. Go Atlas. Go Centaur. Go NROL-42.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition of the RD-180 main engine. 1. And liftoff of the United Launch Alliance Atlas V rocket carrying the NROL-42 mission for the National Reconnaissance Office.
Mach 1. Execute. Currently experience a loss of vehicle telemetry.
You are hearing the voice of Marty Malinowski providing launch vehicle ascent data.
OSM, LC. It's the Atlas commentator. Mission is proceeding as expected. We are experiencing loss of telemetry in Denver. However, we're receiving clean data at Vandenberg. Engine has just throttled down. Engine operating parameters look good. Body rates are good. Hydraulics look good. And we fired the power valve, activating the RCS system. Vehicle continues to fly normally. Upon bearing jettison, approximately 15 seconds. Now throttling to a constant 4.6 G. Bearing jet. Turbulences look good. VLFR jettison. Engine is throttling back up to 100%.
This is Atlas Mission Control at T plus 3 minutes 45 seconds. We've just seen the successful liftoff of the Atlas V rocket carrying the NROL-42 mission for the National Reconnaissance Office, and all systems continue to operate nominally. Liftoff occurred at 10:49:47 p.m. Pacific. At our customer's request, we will now conclude live coverage.
As usual for classified launches, no details of the payload or mission were released. However, as usual on SpaceTime, we can draw some reasonable conclusions based on what we do know. The Atlas V was in its 541 configuration. That means the basic launcher was equipped with 4 strap-on solid rocket boosters. That indicates either a fairly heavy payload or a very high altitude, possibly even Molniya orbit. Molniya orbits are highly elliptical, designed to provide extra dwell time over higher latitudes. Vandenberg Air Force Base is especially useful for high-inclination polar and sun-synchronous orbits. These are the sorts of orbits commonly used by Earth imaging satellites, as well as some radar imaging satellites flying in retrograde orbits. NOTAMs, or Notice to Airmen, issued to pilots prior to any launch to ensure clear airspace for both the launch itself and for the jettison and re-entry of spent stages, indicated a south-southeasterly flight path which would be consistent with a Molniya orbit. And that possibly indicates that the payload could be a new SIGINT signals intelligence satellite. Whatever the classified payload, the mission was the 5th United Launch Alliance Atlas V flight this year. I'm Stuart Gary. This is SpaceTime. Russia has launched the latest member of its GLONASS satellite navigation system. The Russian military air and space forces Soyuz 21B rocket, carrying the GLONASS-M satellite, was launched from the Plesetsk Cosmodrome north of Moscow. Mission managers say the launch was successful, with the Soyuz frigate upper stage placing the satellite into its orbit as planned. Mission controls say the 1,415-kilogram GLONASS-M spacecraft is functioning normally in a 19,100-kilometre high medium Earth orbit. A new spacecraft will join Russia's constellation of 24 navigational satellites placed into 3 medium Earth orbit planes of 8 satellites each. The GLONASS system was developed by the Soviet Union in the late 1970s in direct response to America's GPS Global Positioning Satellite Navigation System. The GLONASS system achieved operational capability in 1993, with the full constellation operational 3 years later. The latest M-series generation of GLONASS satellites broadcast 4 L-band navigation signals. 2 are highly accurate and restricted to Russian military use, while the remaining pair are open for civilian user access. The mission was the 31st launch of a Soyuz 2 rocket from the Plesetsk Cosmodrome in the past 13 years. It was also the 3rd launch of the rocket from the Cosmodrome this year. A further 20 launches using the Soyuz 2 have been carried out from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The next Soyuz mission will launch from Baikonur at the end of October, carrying the Progress MS-07 cargo ship on a resupply mission to the International Space Station. You're listening to SpaceTime. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. And new research indicates that the growth of certain aggressive brain tumours can be halted by cutting off their access to a signalling molecule produced by the brain's nerve cells. The new study, reported in the journal Nature, found that when the signalling molecule neuroligin-3 was absent, or when its signal was interrupted by medication, high-grade glaucoma cancers do not spread in the brain. The findings suggest that interrupting the neuroligin-3 signal could be a helpful strategy in controlling high-grade gliomas in human patients. High-grade gliomas are a group of deadly brain tumours that include glioblastomas. 5-year survival rates are only around 10% for both adult and pediatric glioblastoma patients, and so new treatments are urgently needed. The new findings build on prior research showing that neuroligin-3 fueled the growth of high-grade gliomas. This was surprising because the protein is part of the normal machinery of neuroplasticity in a healthy brain, and it's a relatively new concept that cancer can hijack an organ's healthy function to drive cancer growth. Now, it's important to note that a lack of neuroligin-3 doesn't kill the cancer cells. The cells that are there remain there, but they do not grow. However, 4.5 months after implantation, some tumours began circumventing the dependency of neuroligin-3 and began to grow again. A 9-week expedition to the lost continent of Zealandia has returned to port in Hobart. 32 scientists from 12 countries travelled aboard the research vessel JOIDES Resolution, taking depth soundings and geological core samples of sediments and rock beneath the seafloor to better understand the history of this sunken continent. It was only earlier this year that Zealandia was confirmed as Earth's 7th continent, but little is known about it because it's submerged by more than a kilometre under the sea. The expedition offered new insights into the history of the region, ranging from mountain building in New Zealand to the shifting movements of Earth's tectonic plates and changes in ocean circulation and global climate. Until now, the region had only been sparsely surveyed and sampled. Researchers were able to confirm that Zealandia was already submerged when it separated from Australia and Antarctica some 80 million years ago. Expedition scientists drilled deep into the seabed at 6 sites, in water depths of more than 1,250 metres, that's 4,100 feet. They collected some 2,500 metres of sedimentary core samples from layers recording how the geography, volcanism and climate of Zealandia had changed over the past 70 million years. The data shows Zealandia wasn't always as deep beneath the waves as it currently is. Researchers also collected more than 8,000 specimens for study, and several hundred fossil species were also identified. The discovery of microscopic shells from organisms that lived in warm, shallow seas, and of spores and pollen from land plants, revealed that the geography and climate of Zealandia was dramatically different in the past. The new discovery showed that the formation 40 to 50 million years ago of the Pacific Ring of Fire, an active seafloor zone around the perimeter of the Pacific Ocean, caused dramatic changes in ocean depth and volcanic activity, ultimately buckling the seabed of Zealandia. It seems that since the beginning of time, teenagers have always been a moody bunch, especially when the olds are around. At least that's what we called parents when I was a teen. Now, a new study has found that teens get their bad moods not from their parents, but from their friends. But surprisingly, they don't get depression from their friends. Researchers found that having more friends with worse mood is associated with a higher probability of an adolescent worsening in mood, and a lower probability of improving, and vice versa for friends with better moods. However, researchers also found that this effect isn't strong enough in the negative direction to lead to a significant increase in depression. Still, understanding that mood can spread socially among teens is important for public health policy and for the design of new programs to tackle depression in adolescents. Human remains discovered in a cave in Mexico indicate modern humans were settling in the Americas at least 13,000 years ago. The analysis of a skeleton found in the Charon cave near Tula, Mexico, suggests human settlement in the Americas occurred during the late Pleistocene era. The findings, reported in the journal PLOS ONE, are based on well-preserved pre-human skeletons discovered in caves in Tulum in southern Mexico. Scientists reached their conclusions by dating a set of human skeletal remains by analysing the uranium, carbon and oxygen isotopes found in its bones, and in a stalagmite which had grown through its pelvic bone. The study suggested the Charon cave was accessed during the late Pleistocene, providing one of the oldest examples of a human settler in the Americas. And finally for now, a new study has found that people who tend to trust their intuition, or those who believe that the facts they hear are politically biased, are more likely to hold inaccurate beliefs. The study, reported in the journal PLOS ONE, also found that people who rely on concrete evidence to form their beliefs are less likely to have mispreconceptions about high-profile scientific and political issues. Scientific and political misperceptions have become dangerously common in today's world, with an increased willingness by people to embrace falsehoods and conspiracy theories. Researchers say the trend poses a real threat to society's ability to make well-informed decisions about pressing matters. Scientists examined data from 3 nationally representative surveys that included up to 1,000 participants. Their aim was to better understand how people form their beliefs and how that might contribute to their willingness to accept ideas with little or no evidence to support them. Participants were asked to answer 12 questions. These included whether or not they trusted their gut to tell them what's true or not, whether they thought evidence was more important than whether something felt true, and whether they thought facts are being dictated by those in power. The study also included questions about the debunked link between vaccines and autism and the scientific-based connection between human activity and climate change. They used responses to those questions to assess people's faith in intuition, their need for evidence, and their belief that truth is political. Researchers found that people who believe that truth is shaped by politics and power are more likely to embrace falsehoods. On the other hand, those who relied on hard evidence were far less likely to believe falsehoods. The researchers also evaluated the survey respondents' tendency to agree with 7 well-known conspiracy theories. More than 45% said they didn't buy that JFK was murdered by Lee Harvey Oswald alone, 33% agreed that the US government was behind the assassination of Martin Luther King, and 32% believed Princess Diana's death was orchestrated by the British royal family. Previous research had already shown strong connections between a belief in conspiracy theories and one's level of education, religious fundamentalism, and party affiliations. In this study, belief that truth is political was the strongest predictor of whether someone would buy into conspiracy theories. Researchers also found that those who rely on intuition to assess the truth had a far stronger tendency to endorse conspiracies. You're listening to Space Time. I'm Stuart Gary. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts, or Audio Boom. This has been another quality podcast production from Bytes.com.
This episode of Spacetime has been brought to you by Brilliant.org, maths and science done right. And remember to use our special link so they know you've come from us. That's Brilliant.org/Stuart Gary.